Predicting the upcoming Atlantic hurricane season is challenging due to a unique combination of ocean and climate conditions that have rarely been observed before. This year, the Atlantic Ocean is experiencing an active storm era, characterized by a prolonged period of increased storm activity. Additionally, the sea surface temperatures in the Atlantic are significantly higher than usual, providing favorable conditions for storm development, according to Matthew Rosencrans, the lead hurricane forecaster for the U.S. National Oceanic and Atmospheric Administration, NOAA. However, this year also marks the onset of an El Niño phase within the El Niño-Southern Oscillation ocean and climate pattern. El Niño typically suppresses hurricane formation. Rosencrans mentioned that this particular scenario is not frequently seen in historical records, describing it as a rare setup for this year's hurricane season. The NOAA forecasts a 40% chance of near-normal Atlantic hurricane activity for this year, which is relatively high for an El Niño year. There is also a 30% chance of above-normal activity and a 30% chance of below-normal activity. The agency predicts the formation of 12 to 17 named storms, of which 5 to 9 are expected to become hurricanes with sustained wind speeds of at least 119 km per hour, 74 miles per hour. Among these hurricanes, 1 to 4 could reach Category 3 or higher with wind speeds of at least 178 km per hour, 111 miles per hour. The official Atlantic hurricane season runs from June 1st to November 30th. Different organizations offer varying predictions for the season due to the uncertainty surrounding the role of El Niño. For example, Colorado State University anticipates a below-average season with 13 named storms, while the UK Meteorological Office predicts an extremely active season with 20 named storms, including 11 hurricanes and 5 major hurricanes, Category 3 or higher. The long-term average from 1991 to 2020 is 14 named storms. Multiple groups have submitted their predictions to the Barcelona Supercomputing Center, which allows users to compare and contrast the different forecasts. The predictions show a wide range, ranging from below average to well above average, reflecting the significant uncertainty surrounding the strength of El Niño and the Atlantic's surface water temperatures. Each forecast is based on numerous computer simulations of ocean and atmospheric conditions. The consensus among these models determines the probability estimates. However, NOAA's models have struggled to reach a consensus this year, indicating a high level of uncertainty in the outlook. El Niño's emergence is indicated by abnormally warm waters in the equatorial Pacific Ocean, leading to changes in wind patterns and humidity globally. It affects the strength of upper-level winds over the northern Atlantic, which can disrupt the formation of hurricanes by shearing off the storm tops. Conversely, the warm ocean waters in the Atlantic currently provide energy for hurricanes to intensify. The level of activity in the upcoming season will depend on which of these two forces dominates.